Alright guys, welcome to Doozer shop. I wanted to show you guys something with using a steady rest on the lathe. And I want to show you how to make sure you have your alignment set properly, you know, with the fingers that come in, you know, in the steady rest, the fingers. Not too many guys are methodical with how they set it. Sometimes they just tighten them up till they just barely touch, and I used to do that until I found like a better way. Let's take a handheld and let me shake the camera and show you exactly what I'm talking about. So let's go. And as you can see, I have been working. I got too many drawers open, and I've just been making stuff and fixing stuff and just going crazy here in the shop. But anyways, I wanted to show you a setup I'm working on here. I'm drilling through that, it's like 20 inches, that bar, and I got a hole started. And what I did is initially, you know, I set the forge jaw for, you know, zeroed it out as good as I could. And this bar I measured in V blocks, and it was bent like 6/1000 over 22 inches or something like that. And I put it in the press, the green press, with V blocks and all that, and I straightened it within 0.5 over, you know, 20 or 22 inches. So, and you know, that's a little bit skill, a little bit luck, a little bit divine intervention to get it that straight. But anyhow, so back to what I was saying, I centered it up in the forge jaw, and then, you know, it sticks out and it's going to whip a little bit. And I think it had, I don't know, maybe 0.005 or 0.008 of whip. So you tighten up your fingers, right? You tighten that one, the two bottoms and the top, and you just kind of bring them to, and it'll be close enough to get you going to drill a center drill hole, you know, drill a starter hole for with a centering bit. So you put the center drill in, and I know I've got a dowel pin in there. You put a center drill in, and if you're off a little bit, it'll still find center and get you a good enough center. And then what you do is you put the ball bearing live center in there in the center drill hole you just created. So now you know, because it was rotating, if it was off center because the steady wasn't set just perfect, it doesn't matter, because it carves out a hole that, it's like a boring bar. It doesn't need to be centered. A boring bar does not, a boring head with a boring bar, it doesn't need to be centered. It'll cut whatever size hole about whatever center it's rotating upon. Don't know if I explained that correctly, but so again, you drill your center hole, you put in the ball bearing, or it could be a regular, you know, dead center. You loosen up the fingers. You engage your center point into your newly drilled center hole in the workpiece. So now everything should be in line, on center. And then once your live or your dead center is engaged in your newly drilled hole, then you bring the fingers back in. right? And once the fingers are in, lightly tensioned and locked down and lubricated, then you can take out the center and commence with drilling your actual hole or whatever you're going to do. Now the problem with that is your adjustments are they're very close because you used that center and then you brought them just up to touch, and it should be really close. But things happen and sometimes you need to readjust. If this gets hot, you want to slacken off one of them, or it gets you close, but it doesn't get you super accurate. So I'm going to kind of show you what I do to get these fingers set really close so you have zero run out and it follows the true center of the spindle in the lathe, even though you got some whip from just the natural, how straight can a shaft be? It can be pretty darn close, but whatever. Let me grab a dial indicator. I was over here setting up a taper on the Brown & Sharp 13, the mighty Brown & Sharp 13. That's a number 9 taper pin, 1/4 inch per foot. So that's all set. I can steal my indicator carefully. Carefully. Okay, it's magnets. Okay. And da-dee-da-da-da-da. All right. What I'm going to do is stick the magnet on the end of the bar. Okay. Okay. It's pretty strong. I like that. Let me put you down. I know this is not optimal. Okay, you can kind of see that. Let me arrange the linkage here. Okay, let me get you close. Da 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 da. Is this tight or is this loose? This is tight. Loosening the tailstock. Okay, that's not too bad. Okay. So, what I got here, sorry if my fingers are in the way, my arm is in the way. Yeah. So you got the magnet on the bar, you got the linkage. I should have tightened up that linkage, doesn't matter. And I got a dowel pin, it's a black dowel pin. And it's, all right, where are we? Right there, whatever. All right, we're kind of on zero. What I'm going to do is reach over and I'm going to turn the chuck. And this should be close. I mean, the focus and the lighting is just terrible. All right, so that's 0 on the side, it's 0 on the top. All right, it's a little bit less on the side, but I had it pretty close. Maybe I can tweak that in. Okay, but my point is, with this mag base stuck on the end of the bar, you're indicating a pin held in the tailstock spindle, right? And this thing was way off, man. I mean, this thing was 10 or 15 thousandths off. So you got to adjust the two bottoms to get, you know, when you're indicating the side, to get that zeroed out when it's on the front and on the back. And like I said, for some reason, on the back, let me flip the lens finder around. I'm like 2 thousandths off on the back. Well, yesterday was pretty good. I wonder if the bottom, come on baby, you can't. The bottom looks pretty good. You know, if I go back to the top, I'm just losing you guys with the viewfinder. Yeah. I mean, it's close, and it's not important, you know. I'll double check it before I start drilling again. But I just wanted to talk about this topic of indicating. So if you indicate your tailstock, this is essentially what you're doing, right? If you want to indicate your tailstock, you know, you put your indicator linkage, you know, right at the chuck without a bar, or it doesn't matter. I mean, you could do this. So what we're essentially doing is lining up the tailstock to the bar. And like I said, if you were right at the chuck, ideally you want to set the tailstock up at the chuck, but this is the same thing. You know, you grip the indicator in the chuck jaws, or you can put the magnet somewhere on the chuck jaws, it doesn't matter. Usually you just use an indicator with a straight shank, and then you indicate the tailstock. Now I'm indicating a pin, so there's the, you know, misalignment potential of the chuck and the male taper and the female taper and all this. You can swipe the bore. My bore is a little, the Morse taper, I think it's a 4, is a little chowdered up, so this is actually kind of better. So if you're off side to side, you know, you can adjust, there you go. There's an adjustment there for side to side, and there's one on the back, you know, to shift it fore and aft. You know, that's if you're reading the side. If you're out on the up down, you know, where this, let me back up. I think I did a video about this too. Where this split line is, you can put shims, either parallel shims, or you can crook it up or crook it back, you know, up or down. But anyways, just get your tailstock in trim before you start a project like this, up at the chuck. And then once you get your bar and get your steady rest in there, true up and trim up your tailstock. You're not truing and trimming up the tailstock, you're setting your fingers, right? So in one operation, you're initially setting your tailstock up to get your lathe running in trim and in true coaxial alignment. That's something you don't do too often. You do if you offset for turning tapers or whatever. But this is something you do not to get the tailstock in alignment, but to get your fingers set, right? So you do the left and the right to get the indicator measuring the side. And for height, you leave the top one loose and you kind of move both of those at the same time to get the height to come in the same as the sides. What I'll do is, I don't know, let's say I'm 6 thousandths low. I'll move one side 1,000th on the needle, the other side 1,000th, you know, go back and forth, another 1,000th, another 1,000th, a final 1,000th, a final 1,000th, to raise it up, you know, and then check your side to side again. And when you get the side to side running good and the top up and down running good, then you lightly crank down and bring the middle upper finger into contact. And I always use some Molly, black Molly oil. All right, so that's the lesson on how to set your fingers on your steady rest. Oh, my lamp is starting to flash. All right, the video's almost over. My ballast is just going janky, but I'll show you this before I cut loose here. That's a drill bit. I bought this on eBay. Let me turn around. That lamp is just I don't know why it does that every now and again. This is pretty cool. This says Made in USA ITW. I don't know if that's Illinois Tool Works or what. I don't think it is, but I don't know. This is 9/16 and it's a thin web. Let me try to focus. It's a really thin web drill bit. It's kind of nice. It almost is like a parabolic bit, but I think it's, forget showing you that because the darn focus is just absolutely terrible. All right, well, thanks for watching Doozer Shop. I hope that helps you a little bit to understand maybe one of the better ways to set your fingers on your steady rest. So I got to fix that lamp on the ceiling. It stops. See, it does it only once in a while. Anyhow, hope you enjoyed. Have a great evening. Until next time, this is Doozer Shop.